video, in this continuation of the hose, I'm going to get in and just do a little solve on the ending piece. So what I'll do is first iteratively save this, so Control-Shift-S, and we'll just hit the little plus to save this as a second file. And let us hide this and expose the ending. We'll press Alt-V to turn on overlays. And let's shift-click on the eyeball to hide everything inside of it. Normally if you click it, it just hides the object, but if you shift-click it, it hides everything inside of it. We can hide that and that, leaving us with just this piece. And we just want to get in and do a quick solve on it. So I am going to just, I guess the quickest way is to press Q and do a smart apply. And from here, we will just clear any sharps that remain, and also remove any stray shading. From here, let's go back over to our layout tab, and I'm just going to press Alt-4 and we'll bring up nSolve. Maybe we'll also press D and enable the end suite as well. So I'm just going to drag a line across. And during the operation, we want to press Alt to ensure that it's see-through or thicker, so we're able to cut all the way through, and just set up some boundary lines to just kind of set the pace for what is to come. We'll do the same thing here. We see that the line is already thicker because it remembers from the last time that we used it. Very nice. And also let's begin shrinking down the amount of work that is to be done. So just for fun, let's just jump over to Inflow, and I'm going to load up a configuration from Model. And let's see, we actually do not want that one, my mistake. We want to bring up singular cases and just grid fill. And let's jump back over to nSolve and nSuite and continue. Just wanted to give it a little test real fast. For this, we will inset it, and let's jump back to join. The next version of nSolve will have a different looking bandolier whenever it comes to nSolve itself, so be prepared for that. But today is this last outing in its current form. Just looking at this, thinking about how I want to solve it. That's probably the easiest. Let's also Alt-X, and we'll do a bisect mod. While holding Shift on the first click and not on the second, we can just jump this over. And we are just making progress. So I'm going to select this mesh with L and press Control-I, and we can get rid of those little strays that were happening from whenever we converted this into a spin object. Alright, and just looking at this, analyzing what we're needing to do in order to convert this into a subdivision object. For this, we'll press I, we'll press B in order to keep the boundary loop. Just kind of setting the stage here. When I was looking at it from afar, it actually looked a little simpler. Let us bring up our edge loop, but we don't have vert snap enabled. So let's go ahead and Control-Shift-Tab to enable that. And at least now we can snap to that. And we're just solving up what we can, leaving what we cannot. And we'll continue forcing a flow inside of here. Let's grab this whole piece, press E, and we'll just continue sliding this all the way around. And just like that, we have forced the loop. So now we have what I call a differential, where basically the loop that we're connecting it with doesn't have the same amount of spans. So maybe we can do something about that. Let's go ahead and just select every other loop, and we'll just do a dissolve. I was going to just force it to work, but you'll live longer if you just correct it while you're ahead. Alright, let's try that again. And that works. Not my favorite, but it works. So continuing on. Something like that, and we have that solved. So let us reward ourselves with an additional loop there. And now we want a loop that's going across this just to protect this perimeter. So why not? We'll just force ourselves an inset there. I still daydream of a specialized partial inset. Let's go under nSuite and change our tool, or nSolve, let's change our tool from line under Alt to be dissolve. We could have also changed it in the top bar. Always experimenting with the different ways we have of getting somewhere. And we also want to have vertimergy on. Vertimergy is always there for us. Whenever verts just get too close, it'll just hit us with the good old mergy. And we're just looking at exactly how much merging we're having to do in order to solve this. So there's a lot we can get rid of that will actually simplify what we're looking at. And even though we've simplified this to a quarter, there still is a lot to be done here. But no worries. The day is long and our work is short, but we are just making progress. So right here, I'll dissolve that just so we can force a loop here and make that connection. And why not give it one more loop and just one more. And we could also have it continue all the way around, but it may not be needed immediately. And even as far as this is concerned, I'm not the biggest fan of having these extra loops here. So let's try diamond solving it like so with a slight reduction. You know, it's not feeling like a chef here. Let's take this and we'll slide this over. I'm going to just select these 2 points, press J, so that we can actually get rid of everything in the middle, and we end up with something that actually goes in that direction, flows in that direction. From here, we'll place a loop along the side. We'll snap here. Alright, this song I'm listening to is a 5-star. Alright, my apologies for that small sidetrack. And continuing on. And now we look at this area and we just ask ourselves, what's the easiest way to reduce it? So my brain always says to go across and then come down the middle. Most linear way of a reduction for me. So for this piece, we do want to have a flow that connects with this flow, so we'll press I. And I've been playing a bit of Tetris lately, so reconnecting with topology brings me right back with seeing the puzzle solving potential that happens in 3D. You know, now that we've kind of forced ourselves a little section here, we'll do a collapse. And for a moment, I almost wanted a knife, but I don't need it yet. We'll give this area a loop that will dissolve. And just thinking about how we want to handle this. Probably like so with this one. You know, the only thing I'm thinking about is how I want to solve this while keeping the hard edges that we have going on here. And where join fails, knife right there for you. Knife has your back. So for this edge, we want to use offset. And I love being able to drag off join and have it jump into basically line. That is one of my favorite things because I spend so much time in join. So I never want to truly leave join. I just need join to be in a different state for a moment. So let us disable mirrors so we can actually see what's happening here in this middle area. And if we correct this fast enough, we won't lose the plot with our geometry here. Something like that. In fact, if we're curious in how we're doing, we can always turn on polygon debug, which looks a little intense in my opinion today. But as we make corrections, it'll get right. In fact, I'm looking at this part thinking about, do we add a hard edge along this, or do we solve this before it becomes this level of problem in advance? Do we just let the subdivision gods take it, which is also an option? And as always, while recording, I'm getting inundated on the old anxiety watch. So fully connecting to a relaxing Zen state will have to wait. Alright, and we are making good progress. I mean, is our goal to get all quads? Not a single try remaining. Let's take a look at that and see what that journey actually involves. Let's get rid of that. We can place our triangle there, or we can have our triangle where we had it, which is here. And if we have it here, then whenever it mirrors, they both become a quad anyways. But no need to be so particular about it. Same with this area. We are just walking this triangle to a region that we want it to be in. I was kind of wanting it to be similar to this area over here. Alright, and in the other corner, arguments. Gotta love those. And breaking it out into 3. Just for today, we're going to reduce that to 2 and continue on with our battle. So the majority of this is solved. We do have an area here. Our normals were flipped, so we weren't seeing it, but now we are. So we now have that part corrected. If I wanted to truly get rid of that, we would have a loop go there. If I wanted to correct this, we could have a loop going here, and then we would offset to try here and then correct it there. In fact, let's do it just in case you didn't believe me, and in case you're watching this saying, no, I believed you. Well, too late now. Just kidding. Let's grab this edge, which goes all the way to the other side, along with this one that goes along to the other side. We'll offset it. And let's also do the same thing we did with the reduction. But we do have something curious happening on this other side that probably will need to be addressed. So before that, let's just do a few reductions. And I'll definitely be having to check into the curiosity of why the alpha doesn't appear to be taking, having the mesh so blood Kool-Aid red. this up, connect. We'll dissolve that edge for now. And the amount of work we have left is so minimal, but we are almost there. In fact, just thinking about the most linear way to go throughout it. In fact, I don't like how this part basically defeated me. In fact, I almost want to offset these two edges just so we're able to survive this. So let's give that a try. We'll turn off overlays for just a moment, just so we can see what tarnation is going on. So far, so good. At least we aren't getting the situation we were looking at before, whenever it came to getting things over on the other side. But every cut, you know, I think about them differently now as I solve them all the time. I think about how every cut is basically an IOU for you to solve later, depending, unless you want to you know, take shortcuts. But you know, if depending on how you work, sometimes you find yourself having to solve these things later. Also, looking at this, I'm going to select this whole ring. Let's try that again without that part, and we'll just expand that out. And all this loop is doing is kind of just forcing the topology to work. You know, one of my favorite ways to work is just forcing it to happen and then solving it. Alright, we'll hide this part for now just because it's getting in my way. And let's look at this. And this part is definitely going to be what we call a fun time in the solving community. Because even giving myself a little bit of an offset, I still have pushed the geometry in a way where the mesh doesn't completely like that. Let's push this out. Let's bring this part over. You know, we just have so many near misses, so it's hard to tell exactly who belongs where. In fact, for me, when in doubt, it's always a reduction. We'll look at this from the bottom. Use line. Let's try that again. We'll use line. Alright, and we at least now have it sectioned off. Our new strategy is now to solve and escape. Alright, so maybe this part would be better off merging here. Alright. And this face just keeps on getting in the way. these two edges too close together, which means one of them has to go. Alright, there's going to be a little bit of try action happening here. So yeah, with this back part, I bit off more than I could chew. We're just sliding it back down, and we just have so many extra parts coming out of this, but we don't want to get ourselves lost here, so let's just connect these to their nearest jump points. In fact, let's see how good we did. Or how bad we did, depending. Alright, and that is not how I want to solve that. And we're just experimenting with solutions here. Sometimes all it takes is a bevel and a reduction to get rid of that. Okay, I was looking at that thinking that should not be a try. So we just only got 2-ish. Alright, and we solved that. How good did we solve it? We won't know until we put a subdivision on it. But we definitely got ourselves into a pickle there, didn't we? So let us press I. We'll inset this area as well. Just moving forward as I get accosted by cats. God, Apple, get out of here, you freaking bum. Alright. I'm not a bad owner. She literally meows all day. Don't even know what it means. Ask AI all the time. Why does a cat meow? She's just looking at me. Alright, looking at that part, just thinking, reduction, maybe a reduction. Let's GGEF, some of my favorite hotkeys, GG to slide, E to make it even, F to flip. They just come in handy so much whenever it comes to edge modeling. You know what, we'll reinforce it on this side just so we have an edge to send this way. All solved. And a loop in the middle just to ensure that that remains solved. And just like that, we are good to go. So we are getting near the end of this. However, we are not quite there yet. Alright, so do we need this loop anymore? Yes, we do. Sometimes it can be dangerous just to get rid of edges willy-nilly. But let's go ahead and wrap this area. Alright. And let's grab this, and I guess we can dissolve it now. But do we? Let's keep these both even. That'll at least give us something to solve there and there. Getting a little distracted by Z fighting on the visual here, but there's always something to improve and always something to check in on. All right. 1, 2, and so for this part we can let it solve inside of itself. We'll bring this one all the way down. And for this area, almost feel like some sort of guardian edge is recommended, where we have this area being protected, and then we have this area also being protected. And I'm just going to get message blasted until this video ends, or I'll pause and respond. We are nearing the end. Always a time to get elated. Time for your state to get elated. And we just solved that with 2 and a loop in between. 2 triangles facing each other is able to easily be solved that way. That loop went all the way there. What if we didn't want that to be a triangle anymore? We could reduce it like so. It's not really necessary, but we did it. In fact, that's not necessary either, but we also did that. And we could offset this to be wherever we want this triangle to be. I just prefer it to be outside in that area compared to where we had it. So with that, we are now able to solve that, and finally we are looking at this piece with just an inset. We are now looking at what we must solve finally. For something like that, we'll give this area a loop. And we're at the half-hour mark, so not very long as well. I just figured a nice little quick solve would be a fun little video just to get in and play with a little nSolve. This part at the top will be an area of contention. I'm just thinking about how I want to deal with it. We'll dissolve that edge just so we can create an edge loop going all the way up and around. G, G, E, F, F again to flip it to the opposite. Apple is telling me it is time. time to wrap this. Let's grab this, subdivide it. We'll force a loop to terminate early so that we can then turn that into a diamond quad. Now we have something a little bit more manageable happening. So now for this part, I'm just looking at it thinking, is it completely egregious to let it get a little bit of rounding? And probably not the worst. For this one, let us bring this edge just a little bit closer. And now we have this model. Oh, no, we do not. You know, without this face solved at the bottom, we shouldn't have done anything. Just kidding. That's a little dramatic, but we'll do 1, 2, 3, and they all solve 2 quads. So we got lucky there. So now we can look at this and admire our handiwork. So this is our resulting piece now. So now it's been solved to all quads. It would have been crazy if I would have figured out a way to do this with notes, right? But instead, we just want to get in, solve it manually. And I'm just looking at parts, just thinking, should this get an inset? And you know what? I just realized that we accidentally did away with the 32 round extrusion part of the geometry node setup. Just to demonstrate that in action, we will disable the ending and go back into the hose. And we see that while our new hose is certainly here looking good, there's a section that we have happening to it that is no longer even a thing. You know, it'd be interesting would be if we could give it a group, like a vertex group. So let's go back to this layer, go back to this, and I don't think this is going to work, but let's try it. We are going to Control G, assign it to new group. If we go into weight paint mode, we can see the handiwork of our new group that we created. And so with that, we can now disable this piece, go here, and attempt to replace what we have as our selection done by a 32 round circle being located that was facing down. We can now try something where we try to find our literal vertex group. So let me save this file and we'll give that a try. Alright, so what I want to try is we'll click on this in order to pin this, and I'm going to go under empty, or go under ending, and we're going to locate the group, and I'm going to try to click and drag the group in here, but we see that that doesn't work. So we'll just bring up a named attribute, and this named attribute is going to be the group that we created. We probably give it something better than that, like you know, ending, you know, probably makes more sense. So that way it comes up logically. If we look at this through our viewer node, let's double check and make sure that we have it working. Alright, so we have that. Let's connect our attribute. We'll cut our connection just so we look at the first one, and we see that we are getting more of it than we need, and also we're getting more geometry than we need. So let's go to the ending geometry. Let's disable subdivision for that, because we probably give it one in the end. And since our group is grabbing a little more, let's use a compare, and we'll just clamp that maybe to what was it, 0.7? So just 0.99. Alright, having some fun here. Alright, and I'm sure I could put it to less than something else. Alright, so we have this, and now it'll go through, receive a few iterations, and we see that everything's working out successfully. So we have gotten in here. Okay, some settings were never exposed. for example, this one. We'll use a map range just so we give it a 0 to 1 area. So that feels like a minimum. And the maximum is something like that. Let's connect this up, but we also want to use a input, group input. Wrong one. Let's locate value. We'll just call it extrude 0 and 1. And our min, we can just adjust our min and our max just on the fly. But just like that, we still have our extrude happening, even though we solved this with subdivision. It's just a really interesting way to even think about this stuff, at least for me. All right, so now we have, okay, so the ending didn't get the happiest ending. Let's see why that happened. It comes down to this, and then we scale it. But maybe we don't want to scale it like we were. We want to scale it like this, and then we can extrude it, but we don't want to extrude it individual. Maybe something like so. What are you cats doing? Both of you cats are in here? Tell you, we call that rich in cats. You know, if we have no cats, call it cat rubbed. It's like I'm cat rubbed right now. I ain't got a single cat in here. Alright, so we will put this down as the min. And for the max, we'll put something like that. And this is unnecessary. We could also just play with the values to make them work within the range, but just make it look pretty. So this one is the inner extrude going from 0 to 1. Bam, bam, bam. And we could probably have it extrude in order to keep the subdivision goals in mind. But now we can look at this over, and in fact we solved this even though we are using bevel shaders, right? So let's press Alt V. We'll get rid of overlays, and let's ask ourselves, are we using the right version of cycles? Anytime cycles is just the slightest bit slow, I know that I need to go and check CUDA and make sure that we are working correct. Alt VB, and we're just looking for a setup that flatters us. Let's enable overlays, let's enable wireframes. We probably don't need the grid floor, right? The grid floor just hasn't been needed in this particular thing. We also don't really need any other information here. We just want to be able to admire our now quadrified endings to our host that is subdivision friendly. So we can still throw this into subdivision and get it to be even more smooth on its divisions. In fact, let's do that now. We'll just slap a subdivision modifier on it after the fact. So I'm just pressing Control 2. And let's double check and make sure that we aren't carrying anything with us that isn't able to work with this. And just like that, we are now at subdivision level 2. And we'll just let cycles just play us out. So with that, we conclude this video. I just wanted to go in and just do a little bit of nSolve to solve and still connect this thing up in the end to geometry nodes. So I thank everyone for watching, and I'll see you guys on the next video. So even though we ended this with us putting the hole here again to have it go through our extrusion system that we're kind of experimenting with, we can also do more than that. For example, I can re-enable the shape. Let's remove the subdivision modifier since we don't need it. And we are going to just go to this area on the side and just dissolve the geometry that's here, because we are going to inset it, and then with loop tools we're going to convert it into a circle. And let's press I one more time to inset it once more, and let's press Ctrl G, and we just want to assign this to the active group, which is basically the same one that has that. In fact, let's look at it in weight paint mode just to make sure. Excellent. So now we can at least go back and finish solving it, because that was the purpose of this video, right? So we'll press Alt 4, we'll go into nSolve, and just quickly solve this. Alright, thinking very carefully on how it's going to end in all quads. So now that we have this solved into a circle, we can just tab back out, and because it's already part of that vertex group, if we hide this and we re-enable this, we see that we now have our extrusions also happening here on the side, which is a really interesting way for this to work. So let's select this, and we will bring in our inner extrude and then lower our tip iterations, and we can see it taking place not only underneath but also here on the side. So just another way for us to get this to be a little more interesting. In fact, I'm going way too high with my iterations. Let's put it at something like 5. And we could probably have it, you know, flatten it off, inset it, extrude it back in one more time. But now we can truly end this video with it going even further. So now we see that we can solve this into quads, still separate areas off into vertex groups, use it to go inside of geometry nodes for us to perform operations to, in addition to all the stuff that we did when it came to making this into a hose. Another thing too that we could do while we're here is changing resample curve, that instead of it being on count, we could have it work on length, which will probably give us something regrettable because that's probably not the correct one, but it is. So let us hold shift and we just drag this out ever so slightly. Alright, and we'll leave it there. And all that means is that now, no matter what we can't see anything in edit mode because for some reason geometry nodes hides the original mesh, but now no matter how long we make it, it will always have the appropriate pattern going for it. So let's turn that off, let's turn this off, we'll grab the right thing, re-enable it, and now you see that as I move it around, the pattern remains constant without it getting skewed or scaled in, even though we are seeing it dynamically regenerate every time we make movements, just because of the way that dual mesh and triangulate's working when it comes to creases. But with that, we have now completed our goal of just getting in here and correcting this to be a all quad model. So I will end it there. Thank you for watching.